Nicolaus Copernicus, born on February 19, 1473, in Torun, Poland, was a Renaissance polymath who revolutionized our understanding of the universe. Raised by his uncle, Lucas Watsonrode, the Bishop of Warmia, after his father's early death, Copernicus received an extensive education that would shape his future work. Copernicus began his academic journey at the University of Krakow in 1491, where he studied liberal arts, including astronomy and astrology. His education continued in Italy, where he studied medicine and law at the universities of Bologna and Padua, eventually earning a doctorate in canon law from the University of Ferrara in 1503. During his time in Bologna, Copernicus met Domenico Maria Novara, a prominent astronomer who became his mentor and likely sparked his interest in questioning the prevailing geocentric model of the universe, the idea that the Earth was at the center of the universe. Novara introduced Copernicus to the work of Johann Müller, Regiomontanus, another skeptic of the geocentric model. Copernicus developed his heliocentric theory, the idea that the Sun was stationary and the planets, including Earth, revolved around it, through a careful analysis of planetary models and a desire to resolve inconsistencies in the prevailing geocentric system. His initial motivation stemmed from dissatisfaction with the equant, a mathematical concept used in geocentric astronomy. This dissatisfaction led Copernicus to observe other violations of uniform circular motion, which ultimately guided him towards the heliocentric model. Through years of meticulous observation and calculations, Copernicus concluded that placing the Sun at the center of the universe could better explain planetary motions. His theory proposed that the Earth had three distinct motions: daily axial rotation, annual rotation around the Sun, and a third motion related to precession, or slight variations in a celestial body's axial tilt. By positioning Mercury and Venus between Earth and the Sun, Copernicus could account for changes in their appearances and explain the retrograde motion of planets like Mars and Jupiter, or the apparent backward movement of a planet in the sky, caused by Earth overtaking it in orbit. This comprehensive model, while still using circular orbits rather than elliptical ones, laid the foundation for a revolutionary understanding of the cosmos. Nicolaus Copernicus produced several influential writings in which he presented his ideas and thus revolutionized our understanding of the cosmos. His most significant works include the Commentarialus, written sometime before 1514, was Copernicus's initial outline of his heliocentric theory. This unpublished manuscript, circulated only among close acquaintances, presented a succinct description of his heliocentric model without detailed mathematical calculations. De revolutionibus orbium coelestium, on the revolutions of the celestial spheres, published in 1543, was Copernicus's magnum opus. This comprehensive work, divided into 6 books, detailed his heliocentric model and supporting calculations. Book 1 presented the overall heliocentric theory, while subsequent books covered topics such as spherical astronomy, apparent solar motions, lunar orbital motions, and planetary motions. In De revolutionibus, Copernicus proposed that the Earth is one of several planets revolving around a stationary sun. Here, he also stated that the Earth has 3 motions: daily rotation, annual revolution, and annual tilting of its axis. Finally, he noted that the retrograde motion of planets is explained by Earth's movement. Copernicus dedicated De revolutionibus to Pope Paul III, explaining his motivations and noting the potential for improving the calendar. The work challenged the long-held geocentric model and laid the foundation for modern astronomy, despite retaining some inaccuracies such as circular planetary orbits and uniform speeds. Copernicus' work laid the foundation for future astronomical advancements. He developed techniques for more precise measurements and observations, expanded knowledge on celestial mechanics, and contributed to principles now used in satellite imaging systems. His ideas influenced later astronomers such as Galileo Galilei and Johannes Kepler, who further developed and refined the heliocentric model. The Copernican revolution, spanning over a century, culminated in the work of Isaac Newton. Newton's laws of motion and universal gravitation provided the mathematical framework that solidified the heliocentric model. This shift in understanding the cosmos had far-reaching implications beyond astronomy, shaping modern physics and chemistry. Interestingly, Copernicus was not the first to propose a heliocentric model. Around 200 BC, Aristarchus of Samos had suggested a sun-centered system, but his ideas were overshadowed by Aristotle's influence and the prevailing common sense of the time. Copernicus initially acknowledged Aristarchus in his work, but this reference was removed before publication. Copernicus' legacy extends far beyond his lifetime. His willingness to challenge established beliefs and pursue scientific inquiry paved the way for the scientific revolution. Today, we recognize Copernicus as a pivotal figure in the history of science, whose ideas continue to influence our understanding of the universe.